Let us solve some example problems. Find the zeros of the quadratic polynomial x squared plus 5 times x plus 6 and verify the relationship between the zeros and the coefficients. By splitting of the middle term, x squared plus 5 times x plus 6 is equal to x squared plus 2 times x plus 3 times x plus 6. That simplifies to x plus 2 times x plus 3. So, the value of x squared plus 5 times x plus 6 is 0 when x plus 2 equals 0 or x plus 3 equals 0. That is, when x equals minus 2 or x equals minus 3. Therefore, the zeros of x squared plus 5 times x plus 6 are minus 2 and minus 3. Hence, sum of zeros will be minus 2 plus minus 3 equals minus 5. Similarly, product of zeros will be minus 2 times minus 3 equals 6. By equation of relationship of zeros and coefficients. If x squared plus 5 times x plus 6 is a quadratic polynomial, then the sum of the zeros will be the negative ratio of the coefficient of x to that of coefficient of x squared. Also, the product of the zeros will be the ratio of the constant term to that of the coefficient of x squared. So, sum of the zeros will be minus of 5 by 1 equal to minus 5. Product of the zeros will be 6 by 1 equal to 6. Since the result from both the methods is same for both the sum, as well as the product of the zeros, we have successfully verified the relationship between zeros and the coefficients. Find the zeros of the polynomial x squared minus 5 and verify the relationship between the zeros and the coefficients. From the identity a squared minus b squared equal to a minus b times a plus b, we can write x squared minus 5 equals x plus root 5 times x minus root 5. So, the value of x squared minus 5 is 0 when x equals root 5 or x equals minus root 5. Therefore, the zeros of x squared minus 5 are root 5 and minus root 5. Hence, sum of zeros will be root 5 plus minus root 5 equals 0. Similarly, product of zeros will be root 5 times minus root 5 equals minus 5. By equation of relationship of zeros and coefficients. If x squared minus 5 is a quadratic polynomial, then the sum of the zeros will be the negative ratio of the coefficient of x to that of coefficient of x squared. Also, the product of the zeros will be the ratio of the constant term to that of the coefficient of x squared. So, sum of the zeros will be minus 0 by 1 equal to 0. Product of the zeros will be minus 5 by 1 equal to minus 5. Since the result from both the methods is same for both the sum, as well as the product of the zeros, we have successfully verified the relationship between zeros and the coefficients. Find the quadratic polynomial, the sum and product of whose zeros are minus 5 and 6, respectively. Let us assume the quadratic polynomial be ax squared plus bx plus c, and its zeros be alpha and beta. We have alpha plus beta as minus 5. Alpha times beta as 6. In the general form, sum of zeros will be minus of b by a, and product of zeros will be c by a. In its simplest form, a is 1 implies b is 5 and c is 6. So, the simplest quadratic polynomial which fits the given conditions as x squared plus 5 times x plus 6. But in general, the family of quadratic polynomials satisfying the above conditions will be represented as k times x squared plus 5 times x plus 6, where k is real. Verify that 3, minus 1 by 3 are the zeros of the cubic polynomial p of x equals 3 times x cubed minus 5 times x squared minus 11 times x minus 3, and then verify the relationship between the zeros and the coefficients. The general form of a cubic polynomial is a times x cubed plus b times x squared plus c times x plus d. So, comparing the coefficients with 3 times x cubed minus 5 times x squared minus 11 times x minus 3, we have a equals 3, b equals minus 5, c equals minus 11 and d equals minus 3. For a real number k to be a zero of a polynomial p of x, it should satisfy the condition p of k equals 0. So, if k is 3, p of 3 equals 3 times 3 cubed minus 5 times 3 squared, minus 11 times 3, minus 3 equals 81 minus 45 minus 33 minus 3, which is 0. When k is minus 1, p of minus 1 equals 3 times minus 1 cubed minus 5 times minus 1 squared, minus 11 times minus 1, minus 3 equals minus 3 minus 5 plus 11 minus 3, which is 0. When k is minus 1 by 3, p of minus 1 by 3 equals 3 times minus 1 by 3 cubed minus 5 times minus 1 by 3 squared, minus 11 times minus 1 by 3, minus 3 equals minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3, which simplifies to minus of 2 by 3 plus 2 by 3, which is 0. Hence, we have verified that 3, minus 1 and minus 1 by 3 are the factors or zeros of the given cubic polynomial. Now we know for a cubic polynomial ax cubed plus bx squared plus cx plus d. The relationships are as follows. Sum of the zeros equals negative ratio of p to a, that is minus of minus 5 by 3, that is 5 by 3. Product of the zeros taken 2 at a time equals c by a, that is minus 11 by 3. Product of the zeros taken all 3 together equals minus t by a, that is minus of minus 3 by 3, that is 1. From the zeros given, we have the corresponding calculations for sum as 3 plus minus 1 by 3, that is 5 by 3. For products taken 2 at a time as 3 times minus 1 plus minus 1 times minus 1 by 3 plus minus 1 by 3 times 3, which simplifies to minus 3 plus 1 by 3 minus 1, that is minus 11 by 3. For product taken all 3 together as 3 times minus 1 times minus 1 by 3, that is 1. Since all the 3 attributes have the same results from zeros as well as coefficients, we have successfully verified the relationships between zeros and coefficients. Please pause the video, rewind and play again to absorb what has been covered in the topic. Let us proceed now.